All right, good morning, guys. Welcome back. It's Monday, October 27th. We're going to continue on with our circle stuff. All right, so on Friday we started looking at circumference and arc length of circles. So today we're going to take that a step further and look at area and sector area. All right, so you guys kind of flip back over to the notes you guys got on Friday. We're going to look and just remind you guys about what area is and what the sector of a circle is. All right, so remember on Monday or Friday we talked about circumference was the perimeter around the circle, and arc length was a piece of that perimeter. We talked about sector, and I kind of like to think of it as a piece of pie, like a pizza or something like that. It's that little triangular looking piece. That would be the sector. So it's a piece of the entire area of the circle. All right, so circumference we talked about was 2 pi r, or you could say pi times d, because your diameter is 2 radii. All right, and then the area, and this is kind of what we're going to be focusing on today. All right, your area is going to be pi times whatever your radius is squared. All right, so really, as long as you know your radius, you can find your area. If you know your diameter, just cut it in half or divide it by 2, and that's your radius. You can then find your area. All right, so we're going to be using that equation a little more today. All right, so let's go right below that. So on Friday, guys, we did A and C. So today we're going to do B, D, and E on the front side. And then we're going to go to the back side and look at some area stuff. All right, so first of all, first problem, part B. All right, I want to find the area of my circle given my diameter. All right, so if they ask me to find circumference, I'd use my circumference equation, but they're asking me to use area or find area, so I'm going to use my area equation. All right, so remember, I have to know my radius here. Now, in this case, they give me my diameter is 10 feet, which means my radius is going to be 5 feet. All right, that's important because if you plug in a 10 here, that's your diameter, not your radius. I need my radius. So my radius here is 5 feet. So my area is going to be pi times 5 squared. Now, just like we did with circumference last week, I'm going to have two types of answers. I'm going to have my exact answer, which means I'm keeping it in terms of pi, and I'm going to have my approximate answer, which means I'm multiplying out my pi. All right, so my exact answer, if I were to square my 5 squared is 25, so this is 25 pi feet. So that's my exact answer. That's going to be approximately, if I were to take 25 and multiply out my pi, so 25 times pi is going to give me 78.5 feet. All right, so once again, guys, this is my exact, I'm just going to put x, and this is my approximate. Again, it means I'm multiplying things out. So exact, I'm keeping it in terms of pi. Approximate, I'm multiplying out the pi. All right, now let's look at part D. Part D wants me to find the radius given my area. Now, if they said find the radius given your circumference, then I would come back over here and use my circumference equation. But they want me to find my radius given my area. So that means I'm going to go back and I'm going to use my area equation, which is pi r squared. All right. Now, to find my radius, they give me my area, so I'm going to take that area, that numerical value, that's my A value, and I'm going to substitute it into my A. So I'm going to have 201 equals pi times my radius squared. All right, so I'm trying to find my radius here. All right, now my exact value, we're going to do that first, and then I'll show you what that's going to look like as my approximate. All right, so my exact value, I'm going to divide by pi on both sides. Now remember, exact means I want to keep it in terms of pi. So that means I've got r squared equals 201 divided by pi. If you guys remember that in order to get rid of a squared value, the opposite of squaring something is taking the square root. So from there, I would take the square root of both sides, and that would actually be my exact answer, the square root of 201 over pi, and that would be feet for my radius. All right, so my exact value, I'm just going to kind of put that off to the side, would be the square root of 201 over pi. That's my exact, don't forget feet. That's my exact value. So now if I take that and I put in my calculator to get my approximate, I'll take 201 divided by pi, and then take the square root of that number. So 201 divided by pi is pretty much right at 64. So if you take the square root of 64, you should get right at 8. All right, so that's going to be my exact, or my approximate will be approximately 8 feet. So once again, this is my this is my exact, because I left it in terms of pi, and then this is my approximate, because I multiplied everything out and divided things out and just got a decimal. All right, cool. All right, so let's look at this last one here. It says, given the area of the circle is 1024 pi, note there is a pi there, find the radius and the diameter. So once again, they give me my area, so I'm going to use the area equation, which is pi times radius squared. And the biggest thing that people make mistakes here, or the biggest mistake that people make, is they forget to write in the pi for the area. So my area is 1024 pi. Make sure you include that pi. It's going to make your life easier here. Alright, so my area is 1024 pi. That's going to equal pi r squared. Divide by pi on both sides. And this is why it's important to make sure you remember to bring that pi down with it, because your pi's here actually cancel. They cancel on both sides. So I'm left with r squared equals 1024. So to get r by itself, like we did before, we're going to take the square root of both sides. Now the square root of 1024 is a perfect square. It's 32. So my radius here is 32 meters. All right, now to find my diameter, remember that just means I multiply my radius times 2. So my diameter, 32 times 2, is 64 meters. And there we go. All right, so I used the fact that I knew my area, found my radius, and then I found my diameter. Cool. All right, so that should be it on the front side of the notes. What we want to do is we want to go to the back side of the notes and start talking about sector area. All right, so just like when we were talking about arc length last week, guys, with my circumference, area of a sector is a piece of your entire area. All right, so if you guys look down at this first example, the shaded region, this blue region, is a piece of the entire area. It's a fraction of that entire area. So what we're going to do to solve our proportion, just like we're doing with arc length, is we're going to use the ratio of the measure of the arc to the whole degree measure of a circle, which is 360. We're going to use that same ratio to help us solve for the area of our sector. All right, and if you notice, guys, this should look pretty familiar. All right, I've still got the measure of my arc. In the denominator, I'm still going to have 360 degrees. The only thing that's different is I'm going to have my sector area. I'm going to put sector area, or area of my sector, over the entire area of my circle. So it's piece over the whole equals piece over the whole. All right, so depending on what I'm looking for will depend on where my variable goes, depending on what I'm trying to solve for. All right, so let's just use that very similar equation what we had the other day, and we'll go from here. All right, so first part, find the area of the sector. That's all I'm doing. So that's going to be the numerator piece up here. All right, so let's find that area of the sector. I'm not going to rewrite it. I'm just going to highlight that for you guys. Boom. Highlight that a few times. So that's what I'm going to be using right there. So my sector area is going to go in the top left. That's what I'm looking for, so that's my variable. Over. Now, similarly, guys, if I was looking for the area of my circle, I would just put an A there. That's where my variable would go. But because I'm looking for, or I know the area of my circle, I'm going to put in there pi r squared. So pi times my radius, which is 10 squared. A little bit more visible. There we go. Equals the measure of my arc, which this is the arc that I'm looking for. Or this is the area I'm looking for that has a measure of 160 degrees over 360. So just like last week and just like we've been doing all semester, we're going to cross multiply. So I've got 360x equals, and this is going to be 160 times pi times 10 squared. Now 10 squared is 100, so you can just do 160 times pi times 100. All right, you get a pretty large number when you cross multiply. You get 50,000. So 50,265,265 points. If we round that, we get 0.5. All right, so we're going to take that value, 50,265.5, and we're going to divide that by 360 degrees. And that's going to give me that the area of my sector is 139.6. And area is always in units squared. So it's 139.6 inches squared. All right? So that's the area of my sector. What I want you guys to try and do is try and take a couple seconds, and I want you guys to solve for part B. All right, if you guys need a little bit more time, Ms. Miller, if you wouldn't mind just pausing it and let them kind of finish up. And once you guys are done with that, we'll start going over it. So let's look at it. So once again, I'm trying to find the area of my sector, so I'm going to use this highlighted equation up here. So it's the area of my sector over the area of my circle equals the measure of my arc over 360 degrees. So once again, I'm looking for the area of my sector. So that's going to be my x value over my area of my circle, which is pi times my radius, which is 21 here. 21 squared equals the measure of my arc, which the shaded region I'm looking for is 110 degrees over 360. And guys, make sure you pay attention to what you're trying to find, because depending on where that shaded piece is, you got to make sure that that degree measure matches that shaded region. For instance, sometimes they might give you this arc right here, which would be 250 degrees. All right, if this is the area you're looking for, you don't want to use 250 degrees as your measure of your arc. You want to subtract that from 360 to make sure you're using the correct one. All right, so again, make sure you're paying attention to what degree measure they give you. All right, so back to math. All right, so same thing we've been doing, guys. We're going to cross multiply. So we get 360 times x, which is going to be 360x, which equals, that's going to be 110 times pi times 21 squared. So 110 times pi times 21 squared. Another large number, 152,398.7. All right, so we get 152,398.7, and we're going to divide that by 360 degrees. So in this case, we get the area of my sector is 423.3 millimeters squared. Again, area is always in units squared. All right, so just like we did last week, guys, so that's trying to find the area of my sector. They might ask for you to find something else. All right, not just the area of your sector. They could say find the radius. They could say find the area of your circle. They could say find the measure of your arc. But either way, everything is in this equation you need. Just whatever you're trying to find, make sure you plug that into the correct spot. All right, so in both of these problems, they want me to find the area of the circle. All right, so if you guys remember, I'm just going to kind of write it right up here. So it's the area of my sector over the area of my circle equals the measure of my arc over 360 degrees. So once again, I'm going to highlight that up there so you guys can see that. And just keep referring back to it. All right, so that's what I'm looking for. All right, that's the equation I'm using. So in this case, I'm looking for the area of my circle, which again is down here in the denominator. So it's this piece right here. All right, so that's what I'm looking for. So in this case, they're telling me that the area of this particular sector right here, this piece of pie, the area of it is 95 centimeters squared. So that's going in my numerator. They're giving me the area of my sector over. Because I'm looking for the area of the circle, I can just leave that as a, or I can use that as x. All right, if they're looking for my radius, I would use pi r squared in the denominator. But because I'm looking for the area, I'm just going to call that x. All right, or again, you could call it a. The measure of my arc for this particular shaded region is 150 degrees. So 150 over 360. So once again, we're going to cross multiply. So 150 times x, that do be 150x, yeah, equals 360 times 95 is going to give me 34,200. So 34,200. If I divide that by 150, I'm going to get that the area of my circle is 228 centimeters squared. There you go. So the area of my sector was 95 square centimeters, so I put that in my numerator. I was looking for the area of my circle, which is in the denominator. Cross multiply and solve to get the area of the entire circle is 228 centimeters squared. All right, y'all take a quick second and solve part B. All right, once again, Ms. Miller, if they are not quite done, if you guys just want to pause it and kind of finish up. Key here is trying these problems on your own before we go over them. You have to do them on your own on the quiz and test, so make sure you guys can take care of those. All right, so let's take a quick second. Let's go over this. So once again, we're looking for the area of the circle. All right, so again, that goes in my denominator. So the area of my sector they give to me as 123.45. So that's going to go in my numerator over the area of my circle, which is what we're looking for, equals the measure of my arc, which is 70 degrees, over 360 degrees. So once again, we're going to cross multiply. So 70 times x is 70x equals 123.45 times 360 degrees gives me 4, 4, 4, 4, 2. So 44,442. All right, we're going to take that, we're going to divide that by 70 to get my x value by itself. So I'm going to get that the area of my circle is approximately 634.9 meters squared. So the area of my whole circle, the area of my sector was 123.45. The area of my entire circle is 634.9 square meters. Cool. All right. Now this last part really isn't talking about area of the sector or arc length or anything like that. Now we are going to use it. All right, but here we're just looking for the area of a shaded region. All right, and you can kind of think about this first one as a dartboard. All right, so if you kind of see, we've got a smaller circle inside a larger circle. All right, so if I just want the shaded region, typically what you're going to be doing is you want to take the area of the larger figure and subtract off the area of the smaller figure. So in this case, I'm going to find the area of my big circle, because that's going to give me the area of everything inside. All of this stuff here, it's going to give me all of that area. All right, but the piece that I don't want is this smaller figure, so that's the part that I want to subtract off. So I want to subtract off the area of this smaller circle from my bigger one. All right, so the way we're going to write this is we're going to say the area of my big circle minus the area of my little circle. All right, and that's going to equal the area of my shaded region. So we'll say the area of the shaded. All right, so first I want to find the area of my big circle. Then I want to find the area of my little circle. All right, so the area of my big circle, let me go back and erase some of this so we can see it. All right, the area of my big circle is going to be pi times radius squared. So we'll kind of put that up here. So the area of my big circle is pi times, now my radius of my big circle is 9 plus 3.5. It's not just the 9, it's not just 3.5. The area of my big circle is actually 12.5. You add those together. So pi times my r squared. All right, so let's just go back through. Let's put it in the exact terms. It's a lot easier to deal with when it's in the exact terms. All right, so if I were to take 12.5 squared, that's 156.25 pi. All right, 12.5 squared is 156.25. I'm just going to leave it in terms of pi. It's a little bit easier to deal with and subtract when you leave the pi there. All right, so that's the area of my big circle. All right, let's find the area of my little circle. It's the same thing. It's going to be pi times the radius. Now, the radius of my little circle is just 9. All right, so pi times 9 squared, which is going to give me 81 pi. All right, and what I want to do here is I want to subtract off. So again, we said I want to take the area of my big circle minus the area of my little circle, and that's going to give me the area of my shaded region. And typically that's what you're going to want to do, the area of the bigger figure and subtract off the area of your smaller figure. All right, so if, again, they're in terms of pi, I didn't multiply out the pi's. You can if you want to, but you don't have to. All right, so if I keep the pi's there, so I'm going to take 156.25 and subtract off 81. So that means the area of that shaded region is 75.25 pi. That would be your exact area of your shaded region. So the area of the shaded, 75.25 square meters, or that's approximately, if I were to take that and multiply it out by pi, would give me 236.4 meters squared. So either one of those will give you the area of your shaded region. Again, the first one is your exact 75.25 pi square meters, and your other one is your approximate 236.4 square meters. All right, so what I'm going to do is I'm going to take this, see if we can't take this and minimize it a little bit. And we'll keep it there. We'll just kind of shift everything over. All right, so there we go. So now the second one, it's the same concept here. All right, it's the exact same thing, except this time the area of my big figure is going to be a circle. All right, so I'm going to take the area of my circle and subtract off the area of my square. All right, so the area of my circle over, or subtracting off the area of my square. So that's kind of in general what I'm going to end up doing. So first I got to find the area of my circle, and then I got to subtract off the area of my square. That's going to give me the area of my shaded region. Again, typically you want to subtract off the area of the smaller one from the bigger one. Now, to find the area of my circle here, all right, it's a circle, so we do pi times my radius. Now, if you kind of turn your head to the left a little bit, you see that the radius of your circle is actually 10. So it's going to be pi times 10 squared. All right, well, 10 squared is 100, so it's 100 pi. So it's actually going to be right around 314.2 square meters. All right, so I want to subtract off the area of my square. Now, remember, the area of a square is your length or your side squared, or length times width, or base times height. Remember, a square has the same length sides. All right, now the problem is I don't know what the length of any of these sides are of my square. I don't know what any of them are. All right, so I've got to find it somehow. So they only tell me that this piece right here of my circle is 10. All right, we've actually got to use a little Pythagorean theorem here to figure out what it's going to be. All right, so if you notice, this piece is 10, so what's the whole length going to be? All right, very good, 20. All right, now if you notice, now that I've got that, I've actually got a right triangle here. And I know that my sides are congruent. Now, I know my hypotenuse is 20. I know that these two sides are congruent to each other. All right, so if I call this side x, that means this side is also x. So I can actually still use Pythagorean theorem here because I know my sides are congruent. So if I want to say a squared plus b squared equals c squared, this is going to help me find what my side lengths are going to be. All right, so x squared plus x squared, I can't square an x, so if I combine them though because they're both x squared, so that's actually 2x squared equals 20 squared is 400. All right, if I divide by 2, that gives me x squared equals 200. Take the square root, so I get x equals the square root of 200. All right, now we can go through and simplify if we wanted to. All right, but I don't need to here. All right, so I can actually just leave it as the square root of 200. But again, we could go through and simplify that square root, and we'll talk about that a little bit next semester a little bit more. So it's the square root of 200. All right, so my side squared is going to be, my sides are square root of 200. So it's going to be the square root of 200 squared. All right, now when you square a square root, it cancels out. So the area of my square is actually 200 meters squared. So to find, let me move this over a little bit. Line those up a little better. All right, so to find the area of my shaded region, I take the area of my circle, which is, we'll go yellow, which is here. Subtract off the area of my square, which is there. When I subtract those off, I get 114.2 meters squared. So that is going to be the area of my shaded region. So once again, guys, to find the area of your shaded, typically you're going to take the area of your larger figure and subtract off the area of your smaller figure. All right, so the first one we had 2 circles, so I took the area of my big circle minus the area of my little circle. This one was my circle was my larger figure, so I found the area of that, subtracted off the area of my square, which took a little bit of work, but that's okay. And we found the area of my shaded region. All right. Now, tonight, guys, your homework is to finish up the worksheets you guys received on Friday. Hopefully you did not lose it, because that's your homework tonight. Now, some of the problems, like the area of a sector is not on there, but it is practicing with area. Do a little bit of practice and review from circumference and arc length as well. Finish that up tomorrow, guys. We will start into the next section. All right, have a little bit of practice as well, and you should be good to go. So please remember, guys, if you ever have questions, please come back and watch the video again. It's on the website. Also, come back and check all the answer keys. Make sure you're getting the right answers. You got your Khan Academy videos. You got the videos that are also with your book. And you can always come back and ask some of the other geometry teachers, Ms. Stevens, Ms. Caldwell, Ms. Kaufman, Coach Henderson, Coach Call. Any of those teachers are more than happy to help you if you go ask them, but you have to ask them. All right, so I hope you guys have a wonderful day. Happy math, and I will see you guys later.